Leave insert ordinary level to circle exam questions. Question 1a. The diagram below shows three circles labelled P, Q and R. So this circle here, this small one, is circle P. The one outside of it, the larger one, is circle Q. And then the one over to the right is circle R. Write each of the letters P, Q and R in the correct place in the table so that each circle matches its equation. So the first equation we're given is x squared plus y squared is equal to 9. Then we're given x minus 6 to be squared plus y minus 2 to be squared is equal to 4. And then we're given x squared plus y squared is equal to 1. So we have to match either P, Q or R in the box to the left of each of the equations. So if we have a circle with a center 0, 0, the equation of that circle is x squared plus y squared is equal to R squared. So it's equal to the radius squared. This circle here, circle R, has a center of 6, 2. So it lines up with 6 on the x-axis and 2 on the y-axis. So the center is 6, 2. So the center is not 0, 0, so it does not have this equation. So its equation is not in that format. So this equation here must be R because it's the only one that is not in the format of x squared plus y squared equals R squared. Now we can be sure that this is the right equation because the x value is 6 and inside the brackets we have x minus 6 and the y value is 2 and inside the brackets we have y minus 2. So a quick way to generate the center of a circle is to take the number inside each of the brackets. The first one relates to the x and the second one relates to the y, and then just swap the signs. So if we've got minus 6 inside the bracket beside the x, then positive 6 is the x part of its center. And if we have minus 2 inside the brackets beside the y, then positive 2 is the y part of its center. And then just to be sure, we can check the radius. So in our circle equation, whether the center is 0, 0 or not, we always have equals R squared on the right-hand side. So if R squared is 4, then R is equal to the square root of 4, which is 2. So the radius of this circle should be 2 units. And if we have a look, we can see that the radius of this circle is indeed 2 units because the center lines up with 6 and the furthest point on the edge there lines up with 8. So we can see that yes, the radius is 2 units. So now we need to decide if this equation here at the top is P or Q, and then if the one at the bottom is P or Q. So we're narrowing it down. So let's have a look at this one here. So x squared plus y squared is equal to 9. So the square root of 9 is 3, so the radius of this circle is 3. And we know that its center is 0, 0 because it's in the format of x squared plus y squared. And both of these circles here in our diagram, P and Q, both of the circles have a center of 0, 0. So we have to look closely at the radius to decide which is which. So if we have equals 9 here, well, the square root of 9 is 3, so the radius must be 3. So this top equation here must be Q because we can see this is the center, 0, 0, and this is the edge, and it's a distance of 3 units. So our circles are P, Q, and R. So we know this one is Q and this one is R. So this last one must be P, this circle here, but let's just double check. So we have x squared plus y squared. So that means that the center is 0, 0, which it is. We can clearly see the center is 0, 0. And then we have equals 1. So if we get the square root of 1, that will give us the radius, and the square root of 1 is 1. And we can see that if this is 0, 0 and the edge is at 1 on the x-axis, then the radius is a distance of 1 unit. So we are extra sure now that this is the circle P. So this is a 10-mark question, part A. B. The circle C has center 3, minus 1 and radius 7. Write down the equation of C. So on page 19 of your formula book, you have the section for the circle, and it says, given center h, k and radius r, the equation formula is x minus h to be squared plus y minus k to be squared is equal to r squared. So this is given to you in your formula book, no need to learn it off. So here's our formula. So this is when a center of the circle is not 0, 0. So we're going to label our center as 3. The 3 is the h and the minus 4 is the k. And the radius 7 we'll label as r. And then we just have to sub into our formula. So I've written out the formula here, leaving space to fill in the h, the k, and the r. So the h I'm going to replace with 3. The k I'm going to replace with minus 4. And just be careful here because you've got y minus minus 4. Make sure you've got the 2 minuses there. And then the r I'm going to replace with 7. And then we just have to simplify. So x minus 3 to be squared stays as it is. And y minus minus 4 to be squared becomes y plus 4 to be squared. And 7 squared is 49. And there's your answer. Here we have the equation of the circle. So this is a 10-mark question. C. The circle K has a center minus 1, 3. So here's our circle K, and it has a center minus 1, 3. The point 2, 7 is on the circle K as shown in the diagram below. So the point 2, 7 is on the circle K. Part 1, find the radius of the circle K. So the radius of a circle is the distance from the center to the edge. So if we draw in a dotted line here and find the distance between those 2 points, we will find the length of the radius. So the radius is the distance from the center to the edge. So here's our 2 points, minus 1, 3 and 2, 7. We're going to go to our formula book, page 18. Now this is coordinate geometry of the line, but we often use this formula and a couple of the other formulas in the circle question. So the length of PQ, so we see in our diagram up here, we have a line PQ, and the points P is labeled x1, y1, and the point Q is labeled x2, y2. So in our points that we are using in our question, so minus 1, 3 and 2, 7, so this will be the P and this will be the Q. You don't need to write down P and Q, you just need to label x1, y1, x2, y2. So just like we have in the diagram. So x1, y1, x2, y2. Then you're going to write out your length formula or distance formula, which is the square root of x2 minus x1 to be squared plus y2 minus y1 to be squared. So there's our formula. Make sure you write out the formula. You will get marks for just writing the formula. In our next step, we'll write the formula, but we'll leave spaces for our substitution. So we're going to label our points x1, y1, x2, y2. Now I've written out the formula, but left spaces for the x2, the x1, the y2, and the y1. So x2, I'm going to sub in as 2. Then I have minus, because that was already in the formula. And then x1, I'm going to sub in as minus 1. So be careful here because you've got 2 minus minus 1. Then y2, I'll sub in as 7. And then I have the minus from the original formula. And then y1, I'll sub in as 3. You can just stick this straight into the calculator if you want, or you can work it out step by step. So 2 minus minus 1 is 2 plus 1, which is 3. And 3 squared is 9. And then 7 minus 3 is 4. And 4 squared is 16. So we've got the square root of 9 plus 16. Don't forget to keep bringing down your square root every step if you do decide to do it step by step. So 9 plus 16 is 25, and the square root of 25 is 5. So the radius is 5 units. So the distance from the center to the edge is 5 units. Part 2. Hence or otherwise, write down the coordinates of 2 points that are on the circle K other than 2, 7, which is the one that was given in the diagram. give your answers in the form A comma B, where A and B are elements of Z. So that capital Z stands for the integer set, which are positive and negative whole numbers, including 0. So A and B can be a positive number or a negative number or 0. It just can't be a fraction or a decimal. So just to note, when you see the word hence, it means using what you have worked out. So in part 1, we worked out that the radius, the distance between these 2 points, was 5 units. So that's going to help us out here. So what we worked out was that the radius is equal to 5 units. So I've just drawn in again, or is equal to 5. So we need 2 other points and they have to be on the circle. And just again, an integer is a positive or negative whole number. That's what that capital Z stands for. So if this point here in the center is -1, 3, then this must be -1 on the x-axis. So draw in -1 on your x-axis at that point. And if this is -1, 3 on our x and y axis again, then to the right of it, directly to the right of it, on the y-axis, that must be 3 on the y-axis. So draw in where 3 is on the y-axis. Now, if we keep going across, this point here, we can see lines up with 3 on the y-axis. So the y value is 3. But how do I know that the x part is 4? Well, I know that the radius of the circle is 5 units. So I know the edge of the circle must be 5 units to the right of the -1. And -1 plus 5 gets me to 4. So this point here must be 4, 3. So there's one point that we can write down. We need another. So 4, 3, there's one point. Now I've drawn in another point up here. So I find it easiest to use like our compass, so the north, south, east, and western points. So this is the northern point of our center, and it's -1, 8. So how do I know that this is -1, 8? Well, I know that the center point has an x value of -1, and I can see that this lines up with the center point. So the x part is definitely -1. But how do I know that the y part is 8? Where's the 8 coming from? Well, if I know that this is 3 on my y-axis, this center point, and I know that the radius is 5 units, then this must be 5 units. So if this is 3 and add on another 5, we must get to 8. So -1, 8 is another point on our circle. So you only need 2, but I will show you 2 more, just if you want to use a couple of more examples. This point here is also on our circle, and it's -6, 3. So we can see that the y part lines up with the center. So the y part must be 3 because this is 3. But where's the 6 coming from? Well, this is actually -6. So where's the -6 coming from? Well, again, we know that the radius is 5 units. So the distance from here to here is 5 units. And if we were already at -1, and then we go backwards by another 5, we get to -6. So this must be -6, 3. Or minus. So there's 3 points, so let's do one more. So this point here is -1, -2. So the x part, the -1, lines up with the center point. So we know the x part is -1. So where's the -2 coming from? Well, we know again that the radius is 5 units, and we are interested in how this y value is -2. Well, if the center point is 3, and we're going to go down by another 5 units, 3 minus 5 is -2. So that's where the y value of -2 is coming from. So part 1 and part 2 of C is worth 10 marks.